Welcome to Brain Vision.
To make a secure fit, rivets that are larger than the rivet hole are often used, and the rivet is cooled, usually in dry ice, before it is placed in the hole. A steel rivet 1.872 centimeters in diameter is to be placed in a hole that is 1.87 centimeters in a metal at 20 degrees Celsius. To what temperature must the rivet be cooled if it is to fit into the hole? So we're going to start off from our standard formula for length expansion. So change in length is equal to original length times by change in temperature and the coefficient of expansion over length alpha L. So rearranging that to make delta T the subject, because we're looking for a change in temperature, we can say that delta T is equal to delta L divided by L alpha L. So this is just obtained by dividing both sides of the equation by L alpha L. So to get delta T, we observe that our coefficient of expansion for steel, working out these coefficients, so delta L in this case is equal to 1.872 subtract 1.870 subtract 1.872. So delta L is equal to minus 0.002. Our current L is going to be given by our current at the current temperature, so it's 1.872. L is equal to 1.872, and alpha L is to be given by, so the coefficient of expansion for steel is given by 12 times 10 to the minus 6. Now, because we're dividing through the two lengths, our units don't matter here as long as they're the same. So these are both centimeters, so that's fine. They're comparable. If they were different units, we'd have to convert them to make them the same. And this is degrees Celsius to the minus 1. And so substituting these three values into this equation here gives us a delta T of minus 89. So delta T equals minus 89. And doing, so that stepped up there. So delta T from these three coefficients, we get delta T equals 89. T plus delta T equals T final. So T plus delta T, so 20 plus minus 89 gives us minus 69, not 66, my bad. Gives us minus 69 degrees Celsius, and that is our final answer.